In this video, we are going to discuss number 34 of exercise 3.1. So we still are on exercise 3.1. Now we're discussing number 34 of this exercise. So we are given the equation of a curve. And the equation is y is equal to 2 times e to the power of x plus x. And we are given a point, 0, 2. X coordinate 0, y coordinate 2. And they ask us to find the equation of the tangent line to this given curve at this given point. So we know that the tangent line is a straight line. So obviously it has the equation of a straight line, which and the general equation for a straight line is y is equal to the gradient of the straight line. We're going to denote this mt multiplied by x plus the y-intercept of the straight line, which is c. All right. So we have to calculate the gradient of this tangent, which is mt, and we have to calculate the y-intercept of this tangent, which is c. So we start with the gradient, okay? The gradient mt. So mt is equal to the following. So to get mt, to get the gradient of the tangent line, we have to differentiate the given equation of the curve over here. So we differentiate y with respect to x, right? We differentiate the given curve, differentiate the equation of the given curve, and we evaluate that derivative at x is equal to the given point, which is 0. So we evaluate it at the x coordinate of the given point, right? Calculate the derivative, and we evaluate the derivative at the x coordinate of the given point. That's how we find the gradient of the tangent line that we're looking for. So let's go ahead and calculate this derivative, okay? So we'll say, therefore, the derivative of y with respect to x is equal to the following. So we differentiate with respect to x. We differentiate 2 multiplied by e to the power of x plus x. We differentiate this function with respect to x, okay? So when we do so, this is equal to the following. So this is equal to, it's equal to the derivative with respect to x of 2 multiplied by e to the x plus the derivative with respect to x of x. Okay, so we basically apply the sum rule for derivatives, and we differentiate each term in the sum. So this is going to give us, the first term here is going to give us 2, because we take out 2 because 2 is a constant, so we take it out of the derivative, and we are left with the derivative of e to the x, which is e to the x. Remember, the derivative of the natural exponential function e to the x is the natural exponential function e to the x. So that's why we end up with e to the x here, okay? That's why we end up with e to the x here. Let me just write this x again. Let me write the x again, so it's e to the x. All right, plus the derivative of x with respect to x, obviously dx is just 1, right? So this is going to be 1. So there we go. This is the derivative of y with respect to x. It's the derivative of the given curve with respect to f. So now all we do now to find mt, which is the gradient of the tangent line that we want, all we have to do to find mt is we have to evaluate this derivative that we've just calculated at x is equal to 0, where 0 is the x coordinate of the given point. So we have to do that. So we got 2 multiplied by e to the x plus 1, and we evaluate this at x is equal to 0. We do that. So now this is equal to the following. So we go 2 multiplied by e, we substitute 0. So we put 0 here, plus 1, which is equal to the following. So 2 multiplied by e to the 0. E to the 0 is 1. Anything to the power of 0 is 1. So that's basically 2 plus 1, which is equal to 3. So mt then is equal to 3. The gradient that we're looking for, which is the gradient of this tangent line that we want, is 3. So now we can go ahead and write down the equation of the tangent line that we are looking for, which is y is equal to 3x plus c. But let's remember, we still don't have c. We still have to calculate c. We still have to calculate the y-intercept of this tangent line that we're looking for. So let's go ahead and do that. Now to calculate c, we have to use the given point. The given point is this point here, 0, 2, which is like x coordinate 0, the y coordinate is 2. We use this. We use this point to find c. How do we do that? We do that by doing the following. In place of y, we substitute the y coordinate of that point, which is 2. And in place of x, we substitute the x coordinate of that point, which is 0. There we go. And we got plus c. And then we go ahead and we work this out. Now 3 times 0 obviously is just 0. So obviously this implies that 2 is equal to 0 plus c, which is just c. So c is equal to 2. So therefore we can now go ahead and write the complete equation for the tangent line that we are looking for. And that is equal to the following. It's equal to 3. So y is equal to 3 times x plus 2. So this is the equation that we had to calculate. This is the equation that we want. This is the equation of the tangent line to the given curve at the given point. And that completes our video. Guys, if you like the video, please subscribe and like, and also comment.